So once again, we want to say good evening to everybody. I'm Joe Deli Carpini, the Science and Operations Officer at the National Weather Service in Boston. And with me tonight is Alan Dunham, our Observation Program Leader and cruise enthusiast, as you can see by his photo there. And Alan is one of our, I would say, lead investigators when it comes to doing the storm damage surveys. Both Alan and I led teams for the June 1st, 2011 tornadoes. So I'm going to start tonight by going through kind of the how and why we do everything that we do. And then Alan's going to use the June 1st surveys that he did as kind of an example to show, more of an extreme example, but kind of tie everything together that I present as kind of an introduction. So you'll definitely want to stick around for that. Alan has been known to be very entertaining too. So Alan, welcome aboard tonight. It's glad to have you here. And I know you're finishing your shift at the office, but things have quieted down, so that's good.
Oh, glad to be here, Joe, and hope everybody enjoys the presentation tonight.
All right, excellent. So I will go ahead and get started. And first we're going to talk about some of the storm damage survey basics. So, what are we looking for? When do we go out? We don't go out every time there's a thunderstorm wind damage. How we kind of deal with the media, things like that. And Alan will get into a little bit of that as well. But so let's start off. And really, there's three rules that we have in the office and really in the Weather Service as a whole for when we go out. So these are conducted typically for tornado damage or suspected tornado damage, particularly if it's any injuries or fatalities. But really, what we want to do is get the climate record set right. So we want to make sure everything is documented properly. If there was a tornado, we want to document it. If there wasn't a tornado, we need to know that as well. So typically when there's quite a bit of wind damage, we go and check it out. And that goes down to the second thing there, high impact wind damage. So we're talking, not just a few trees down here and there, unless it's suspected to be tornadic. That's, we're talking about maybe a microburst or even a larger scale macro burst over 2.5 miles, where you have numerous trees down or uprooted, maybe some structural damage. This is, think of winds greater than 70, maybe even 80 miles per hour that we'll go and check out, even if we're confident it was straight line wind damage. And then the third one, which most people don't know about, is flash flooding. So we actually go out and survey that. And this is not so much urban flooding unless it's very extreme. It's more in the realm of the small stream flooding. So we had several flash floods in northwest Massachusetts, certainly the ones associated with Tropical Storm Irene. We surveyed that as well. So again, the reason we do this is just to kind of make sure we set the record straight and we document everything for the climatological record. So there are really three parts to the damage survey. It's not just going out and deciding, okay, it was a tornado and this is how strong it was. That's just one part of it. So the first part is what we do with every event is review the radar data. So in some cases, it's clear, whether it could be straight line wind damage or it's clear that there was a tornado. So an example, June 1st, 2011, or the 2018 Cape Cod tornadoes, 2019, excuse me. Those were pretty clear that, there's good radar evidence of a tornado, but it also helps us determine areas to be surveyed. Often, we get quite several, damage reports, maybe dozens of damage reports, and we really need to filter out the areas that we want to spend the time surveying. It's a very labor-intensive process. So the radar definitely gives indications that, whether or not it may be tornadic, but also where was the damage. And then we usually coordinate that with the local and the state emergency managers to kind of help us survey the area. They often know, they're the boots on the ground right away, so they can tell us the areas that are hardest hit. And they often accompany us as well, so we can, point it out to us as we're surveying. Then there's the on-site survey. So we observe the damage, we come up with estimates of wind speed, and based on that, we can assign an EF rating. And I'll go through an example of how we do that. We use videos, photos, drone footage nowadays is very important, especially for areas that we can't access, which can be used in the assessment. And this is often the most time-consuming part. I think a lot of times Alan and I said, oh, we'll be just out a couple of hours. It's just a little area to survey. And it's always double what we expect. You're almost always out twice as long as you think. So it's, again, a very labor-intensive process, but we want to get it right. So we want to make sure we're not just glossing over what we see and we're documenting everything properly. And then we speak with eyewitnesses who maybe have, did they see a tornado? What did they observe? That helps, provide additional clues. So, in that process also, maybe sometimes they saw a tornado, maybe they saw a sheet of, rain, or just, when were the strongest winds? That can help us too. Did the wind come before the rain or after the rain? That's important to know. And then, we always ask, did you receive a warning? If so, did you take action? We always want to make sure the word got out. With tornadoes nowadays, it's the wireless alert on cell phones, same with flash floods. And later this summer, it will be activated for high-end severe thunderstorms. So we can make that an option for, say, gusts of over 70 miles per hour. We want to get everybody's attention. So it's these three things that really go into the whole damage survey. And in some cases, on site, if we can't really tell if it was tornadic or not, we'll come back and review the radar data again, and have a bunch of people in the office review the radar data. So it's almost like having instant replay, going back, okay, here's what we saw the damage, what was on the radar, and kind of correlating the two. So it's not always clear cut, aside from our extreme examples like Cape Cod or June 1st of 2011. So you've probably seen this image before, and we've used this on social media. How do we determine a tornado? What are we looking for? Well, it's the pattern of damage that determines if it was a tornado, not the amount of damage that was caused. So, in a nutshell, tornado damage often looks chaotic. You have larger trees uprooted or crisscrossing one another, sometimes twisting debris. The weaker tornadoes are tough. You don't always see those clues. The Ef4s, the 80-mile-per-hour tornadoes. Sometimes it takes a little more hunting around and investigating. Certainly the stronger tornadoes are usually, more evident. And with these weaker tornadoes, sometimes it's hard to tell if it was straight line wind damage, which we call a microburst, or a tornado. So, as shown here, you can see a little bit of a convergent path kind of toward the center where the trees have come down. So that was a pretty clear-cut case. Again, we conduct these surveys really to find out what happened, for the climatological record too, but also to help us improve our warnings for the future. We use them for training. We'll go back and review these cases, kind of run them in real time for the forecasters to have them be able to issue warnings. So knowing what happened is really important for that process too. So here's a couple of examples looking up from the air. On the left is from Munson, Mass., the June 1st tornado in 2011, and you can see definitely there's a crisscross convergent path here in the middle, trees coming in one side here and going in the other side there, definitely a twisting signal. Whereas on the right, this was May 15th of last year out in Western Mass. You can see the trees are pretty much blown down in the same direction, and this is indicative of a microburst. Sometimes there might be one or two trees that are crisscrossed, but overall, you can see the pattern is pretty much straight from the bottom of the image up toward the buildings there in the center. So how do we rate a tornado? Well, we don't just go out and say, well, these limbs are down, trees are down, this was an EF1. It kind of works backwards. So what we do is first we come up with a wind speed estimate based on the damage, and then what we do is apply that wind estimate to the EF scale. So it's working in reverse. So what we use are called damage degree indicators, and there's a number of them, and we'll go through an example of how they're used. And these are used by the team to estimate the wind speed and eventually assign the rating. So again, the storm surveys take into account the observed damage, but also eyewitness reports and the radar. So it's all three things put together. You can't necessarily just go out and say, yeah, this is a tornado. In some cases you can, but the weaker Ef4 tornadoes, it's not always as evident. So what we're looking for are different damage degree indicators. So we'll go through that by doing a little quick storm survey. And you may have seen this before. We featured this in another webinar, but I thought it was worth going through again. So let's pretend this is a fictional case, but this was actually a case that happened back in, I think, last year, at least the radar. But let's say, for example, we had severe thunderstorms move through the area during the night, and we have reports of downed trees, some damage to homes. The staff tells us the radar data did show some rotation in the storm, but it was pretty weak. It wasn't a classic, tight rotation couplet, but we have a local emergency manager who we get in touch with, and she tells us, yeah, I see some twisting in the damage pattern. Not always the case. Some people get confused by kind of, trees down or branches down, but in a case of a suspected tornado, it's definitely, I would say a storm survey should be conducted. So I would pick up the phone and probably call Alan, who's hopefully not on vacation, and get him out on the road, or any one of our staff who are usually around. So These are the damage degree indicators. Might be a little hard to read, but these are what we use to provide estimates of wind speed. So at the top, we have small barns or outbuildings. Then we go to 1 or 2 family residences, mobile homes, condos, townhouses, motels, and we work our way up to retail buildings, strip malls, a large shopping mall, automobile showroom. Then we get to schools, a junior or senior high school, and then low-rise and high-rise buildings, hospitals. So we go through all of these, and also at the end we have things like transmission line towers, freestanding poles, light poles, flag poles, and then our trees, hardwood and softwood. So there's a difference between the two. So we're going to use the information that we have to kind of go through this. So if I click on the hardwood, this is what comes up, and this is what we actually use out in the field. So we know we have trees uprooted. Let's say there were oak trees and maple trees, for example, hardwood. So we know this is degree of damage. This is a 3. So trees are uprooted. We know we have that. We're not at the point where trunks are snapped, and we certainly have some branches broken, but this is uprooted. This is kind of the most severe damage. So the uprooted maple trees, we go to the chart, and the EXP is kind of the expected wind speed. And this is based on research that's been done over the years, not just in the Northeast, but all over the country. So the expected wind speed is 91 miles per hour. But we have a range here, a lower bound of 76 miles per hour and an upper bound of 118 miles per hour. So, which one you lean toward? Well, if it's a typical, trees are healthy, everything, nothing out of the ordinary, we're going to go close to the expected. If it's a weakened tree, maybe diseased, maybe a little rotted, or not too many trees down, we might, trend a little lower, maybe 80 or 85 miles per hour. And, if it's a grove of healthy trees and the wind speeds seem to be pretty impressive, we might nudge this up a little higher, maybe to 100 miles per hour. But in this case, let's, we'll say about 80 miles per hour. Let's go a little bit lower. We'll say many of the trees weren't, perfectly healthy. Some were, but for the most part, maybe they were, a little bit rotted. So we want to go a little bit lower, not quite to the lower bound, but we'll use 80 miles per hour in this case. Then we had minor damage to a house. So in this case, this would be a 1 and 2 family residence, and the degree of damage is considered a 2. So, and this gives you an idea of what we'd be looking at. So a house with typical construction, asphalt shingles, plywood roof deck, wood or metal stud walls, or attached single or double garage. So we look up the proper type of residence. In this case, we had let's say we had some loss of roof material. Maybe some of the shingles were blown off and the gutters were damaged. So in this case, we consider it a 2. Again, we're pretty close to where we were with the trees. Maybe a little lower, but expected of 79 miles per hour. So that kind of fits our expectation from the trees. You remember it was 91, and we thought it would be a little bit lower, like 80. So now these two numbers are correlating pretty well. The lower bound could be 63 based on the construction of the house. If it's poor construction or an older home, maybe it was already some damage to the roof before the storm, or a well-constructed home, maybe a newer home. We might want to go toward the upper bound. But in this case, I would look at the damage here. I would look at the damage in the trees and kind of correlate the two together. So let's go with the 79, and let's correlate the two together. So what we have, the uprooted trees, we have 80 miles per hour. The damage from the wind, 79. Let's say, for example, we did see a convergent damage to down trees, so we know, that's indicative of a tornado. And what eyewitness saw debris swirling in the air. That's a common thing that we get from eyewitnesses. So we conclude there's a tornado, and for the rating, we bring that over to the EF scale, which is an EF0 with maximum winds of 80 miles per hour. So it's kind of right in the ballpark there, anywhere from 65 to 85 miles per hour. And what we would do is mark the start location where the tornado touched down, where it lifted. So we have a path length, and we also estimate a path width, which is recorded in our storm verification and in the storm data publication, which is the official record of storms from the National Centers for Environmental Information. So we have all that, we put out our statement, and we're good to go. So just show a quick example. This was the EF0 tornado in Millis from last October when we had the derecho come through. And if you remember, you probably may have seen the event review of this. Radar looked pretty impressive and pretty indicative that there was a tornado. We had this, this is the storm relative velocity. So the greens are coming in toward the radar, which is over here. The reds are going out. So you've got convergence all along the line. The wind is flowing away from the radar and toward at the same time. But Also right here, you can see there's a little bit of rotation. Not really strong, but it's there. And you can see the what's called the rear inflow jet, so the air pushing in behind it is kind of bowing out the line, and we get this couplet to come out. And you can see on the reflectivity, a bit of an appendage comes out front, a little curl, and this is actually where the tornado was. So this is pretty much a classic signal for a tornado that develops along the line of severe thunderstorms. And lo and behold, we found out about it actually a few days later. It wasn't right away, because there was so much wind damage from that event. If you remember, we had widespread winds, above 70 miles per hour. But in this case, we sent Glenn out from our office, and he was actually able to find one little subtle clue of a tornado in this, and he took the picture here. So in the image, you have some branches down to the right. You've got some branches kind of coming into the picture, and you've got this lamppost bending in. So you can kind of surmise that, yeah, there was a little bit of a circulation that came right through here. And many times these weak tornadoes are very, very hard to find, very subtle. You maybe only see one or two trees that have a convergent pattern, but in this case there was a little help from our friend the lamppost leaning in. You've got the trees leaning to the right and leaning in from the back of the picture. So that was our convergent signal there. So again, not always easy, but that's why we usually travel at least in teams of two, sometimes three. So we can all kind of come up with our own conclusion. I guess it's kind of like baseball, Alan, where we have our instant replay, and the umps all kind of go over it together. So with that, Alan, I will pass it on to you. We're going to talk about some of the challenges that we experienced conducting the storm surveys on June 1st, 2011. And again, we actually ended up splitting into two teams for this. I led one team from Westfield, where it initially touched down, through West Springfield and Springfield, and then Alan's team took from there and really surveyed the hardest hit areas, Munson, Brimfield, over toward, I believe, Southbridge, where it eventually lifted. So, and then Alan and I went back, I think it was, a couple more days after that to really resurvey Brimfield and Munson, where a lot of the pictures you'll see here were taken in Munson. And we use these definitely as our training exercise for our newer forecasters to help them learn how to conduct storm surveys. So, Alan, I'll stop talking, and I will hand it over to you from here.
Oh, that's okay. I was enjoying listening to you. All right, everybody. As you could probably imagine, that June 1st tornado was a challenge not only for the people that had unfortunately had to live through it, also for us and our teams. As Joe said, we had to go ahead. Next slide, Joe. We had to take a look, and we had to make a plan of attack. We had to know what we had available to us as far as people to go and do it. We had to find out what we knew, and still we had to investigate the makeup of the survey teams. When we have something like this, we want to go ahead and have at least one real experienced person, another person that's got some decent experience, and then someone maybe without as much, so we can use it as a training situation. Then we have to go ahead and coordinate with both state and local emergency managers as where the teams should be investigating, and then we'll discuss with the team members any possible problems we're going to face. So in this one, we had damage reports along a 30 to 40 mile length. We were basically covering up to 400 square miles, and we had the possibility of actually multiple tornadoes. The main one, of course, and then three more little ones that to the north of there. And we had to consider that some areas would not be able to access by land. That's one of the things when you're doing these storm surveys. A lot of times, the road ends and the damage keeps going. So you don't just stop with the road. You have to actually go out and start hiking through some fairly rough territory sometimes. Good job. Okay, with this storm, of course, one of the biggest problems was the political and media interest. We had 10 TV stations. Most of them had multiple teams out there, lots of radio stations, and an equal number of print media. And politically, we had the governor of Massachusetts, Governor Patrick, had both U.S. senators at the time, Kerry and Brown, plus all the other state and local representatives that were out there. And the first thing they want to ask you is, what was it? And it's like, sorry, sir, Governor, we have to go ahead and do our survey. And as you go along, you'll have some people that like to follow you, and sometimes it becomes a matter of where you have to actually learn to dodge them. One of the things that we learned real quick and that I implemented was I said, okay, we're going to have a media interview session at this point at this time, and then another one further down at a specified time. So I made them go ahead and limit themselves to, for as far as media access, to 2 or 3 different media gaggles to go ahead, and that just, because that saves you headaches, because it's awful hard to go ahead and conduct your survey while at the same time you've got, say, well, what do you think? And you tell them very politely, you have to wait till we go ahead and review all our data. Oh, you can tell me. In fact, I had Senator Brown. He ran into me at in Brimfield, and he came up to me and he said, he introduced himself. Well, I knew who he was, and I explained what I was doing. He said, so go ahead and tell me. So what are you leaning towards? I said, Senator, all due respect, I can't say that. And he says, oh, well, you can go with, it probably was a 4, right? And I said, Senator, again, I'm not going to make any determination till we get everything surveyed. Oh, okay. And as he's walking away, he's got 4 fingers down. Well, the reason he wanted us to declare it a 4 was because there'd be more federal money coming in. So, when you're doing these, you can't succumb to any type of pressure. And at the same time, there was a gentleman from one of the local newspapers who kept following me and always showing up where we were. And every time it was, hey, come on, you've got to have an idea by now. And I finally said, I pointed to Senator Brown. I said, see that guy over there? He says, well, who's that? I said, the big one there. Oh, Senator Brown. I said, yeah. He said, well, yeah, what about him? You told him? I said, I wouldn't tell him. So with all due respect, what makes you think I'm going to tell you now? And I think at that point, it finally dawned on him that, hey, these guys have a job to do, and they're not going to come out with a preliminary estimate. And you have to be really careful, even talking amongst yourself, that you don't get overheard, because someone gets, you're just looking at a little piece of the information and saying, okay, well, this is looking kind of like a 2 here. And all of a sudden it's out on the media and Twitter, in the Twitterverse. Weather Service says it's EF2. And it's like, no, please wait. So that is actually a big consideration, especially when you have a large event like this, the amount of different competing interests for that information. Okay, Joe. Okay, another part of doing the survey is the interview. And this is something I try to really stress to our new folks coming on that have never done a survey, because that is, without a doubt, the hardest part of conducting a storm survey. Because you need to talk to these people, but these are people that just lost everything. Their home, their cars, their house, maybe a pet. So you have to be very sympathetic and express, your sympathy for their loss and let them talk. A lot of times you're going to be we're the only face of the federal government they're going to see. And it's a case of, there's nobody to hear me. And so sometimes people go ahead and, express themselves, their frustration and things like that. So I always tell my teams, let the people talk. Now, I also make sure and ask, did anybody suffer any injuries or loss? If they did, you just offer your condolences and then move on. This part of the survey can be real time consuming. I ended up spending 5 hours, my team did, just in Munson. We got out there early in the morning and we went till well after dark moving along the path. So the interviews are the hard part, and you really have to, really be able to show empathy with them, but still get the information you need to know. And I want to, if you just, Joe, go back one, please, to that other one. Notice that, okay, I'm standing up there talking to a couple of homeowners, and you can see it's a couple of different floors that are on top of each other. Now, that's going to come in a little bit later when I talk to you about how we were determining the strength of this one. Okay, go ahead, John. So again, we had to determine the strength. Go ahead, John. Now, we had this one house. It's like, okay, the bicycles are there. It's upside down. How the heck did it get there? How did the house being in that position be reflective of the strength, Joe. And what it was is, you can see right where that arrow is pointing, that's where the house dug in. The house was not blown up and over. It was slid along, dug into the ground, and did a big flip. So where sometimes you're looking at damage, and we'll see it a little bit in a few more slides, of, houses just totally destroyed versus one that the house is still more or less together, just upside down. So that's indicative of what kind of strength of wind you're doing. Go ahead, Joe. Okay, looking at this, I've seen pictures from the Midwest and stuff. So was this Ef4 damage? And one of the things on that one, back one, Joe, still, is you've got that whole floor just kind of sitting there, and it looks like it's sitting on another floor. In fact, you can see the couch in the lower right-hand corner. Lower right, down, there you go. So you've got the couch, so obviously it's on. It looks like this floor is sitting on top of what was once a living room. Okay, Joe. Okay. Now, when looking at this house, again, basically, walls have been destroyed, but you have floors that are in the basement, and this is at least one, and maybe there were 2 floors actually that settled right down into the basement. Go ahead. And here's another one. This was something we actually learned, because on 2 of the days we were out there, we had an expert come up that's on one of the national teams that does these storm surveys from Eastern Region headquarters. And that's where Joe and I learned the term sliders. And so what it is the house is actually sliding along from the wind, as opposed to being picked up or just having everything blown out. So it actually was sliding off of its foundation. And the other thing we have to consider is how old are these houses? This is a part of Munson that was very well established. A lot of these houses dated back from the early 1900s to the late 1800s. So you have to take that construction into consideration, because winds will do one set of damage to a house that's from around 1900 compared to a house that's been built in the last 30 years. Go ahead, Joe. And there's just another picture where the house, you can see underneath it, so the house itself actually slid across. Good. And this is another example where the house slid across, and in the lower left-hand corner, you can see some of those granite slabs, and also in the one in the lower right corner. Go ahead, Joe, next slide. And you can see on these where the house had the marking on that granite of where it slid, hence the term sliders. And these are the type of clues you have to look for to see if a house was, subject to sliding, which has an impact on what you're going to use for determination of the strength. Go ahead, Joe. Okay, this is a newer house. This is on the east side, and it's starting to go back up the hill. And you see most of the damage is just on the left-hand side of the picture with the trees and whatnot. But this house came close to losing its whole roof. Go ahead. Because the wind was coming in underneath, and it was really just nailed down. One of the things they do down in Florida and Texas for hurricanes, they've been instituted into their building codes where you actually have to tie your roof joists to the down to give it extra support. And most of our houses in southern New England don't have those. So if you're going to be building a new house and you're in an area that could have a tornado, which could actually be anywhere, you want to take that into consideration of how you're securing the roof joists to the rest of the joists. Go ahead. Now you have to also look at things that, you can have some damage that looks darn impressive. This is from this shot for the TV, they're looking at it, yes, look at this damage. And basically, the steeple got blown off and kind of crashed as it hit the ground. So it's real impressive for TV, but it doesn't really help us that much with how strong the winds are in that one isolated instance. Good. On this one, this was a metal building with segments of cement walls. And what happened was the roof was torn off, gave way, and you can see on the just to the left of the building, you can see a lot of the girders and ironwork that had been blown off. And once that roof went, the winds were able to get inside. And because it was all cinder block with no real that much reinforcement, a lot of several of the sections of the walls were actually blown out, which gives the indication that the winds might have been stronger than what they actually were. Go ahead, Joe. Here, this was a barn. It was it was before Brimfield. It was between Brimfield and Munson. And we looked at it, and you can see the whole thing's collapsed. And there was actually a person that was caught in there during the tornado and crawled out with really no scratches at all, hardly any scratches, and that was it. Very, very lucky. But she went into the most interior, solid part of the barn she could find and was able to escape serious injury. Okay, Joe. So you've got to take everything you see into account to determine the intensity. And to be honest, we were going back after that first day. We were going back. Do we want to call it a 3? Do we want to call it a 4? And when you're looking at declaring something that strong, that's when our Eastern Region headquarters says, we're going to send somebody up to give you a hand. And so they did. And Joe and I knew this individual pretty well. And so he was actually a joy to work with. And like I said, he taught us about sliders and a couple other things. And so we were able to make the determination that it was a strong Ef4. But again, if we hadn't seen the sliders, if we hadn't taken into consideration the construction of the buildings, how old they were, new they were, whatever, if we hadn't noticed, floors collapsing on top of each other as opposed to everything just being blown to smithereens in all directions, we might have ended up going with the 4. But you have to, this is one of those things where you can't rush a storm survey. As Joe said, we went back out there 2 more times because we knew we had to get it right. And I can't, like Joe said earlier, the number of times it's like, okay, Alan, you got to head out. We got to prevent a possible tornado wherever. And I'm thinking going out, okay, I'll be back in about 3 hours. And I'm out there for 6-8 hours. There was one storm I went to, and I could see where the storm had come down off this big hill. And so I had to go up and see where it started. And I had 2 people from the fire department and somebody from a police officer with me. And so I start walking up the hill, and they said, "Where are you going?" I said, "Up there." And they said, "And you're going to walk it?" I said, "Well, I don't have a jetpack, so I guess I am." And they said, "We'll wait here for you." I said, "Okay." And an hour later, I came back down the hill, and they said, "We thought you're going to have to send a rescue party." But I had to go ahead and not only find out where the damage started, but also make the determination of what kind of damage. And that survey ended up being a Ef2 out in northwestern Mass. Next one, John. So we came up. Sorry about that. Got all choked up. So basically, we did our best practices, which we deployed multiple survey teams, one Westfield through Springfield, and then my team east of Springfield, basically Munson, over to Southborough. We had to, like we said, we had to resurvey the Muntsville-Brimfield area. We also used the Civil Air Patrol so we could get a survey from the air, so that could get us into areas that we just couldn't reach by foot. And again, we had to frequently coordinate with MEMA, the Massachusetts Emergency Management Agency, because that helped us locate areas of greatest damage and to provide escorts into restricted areas, and also to keep them apprised of our findings prior to a release of information. Those people, your state level agencies, the emergency management types, we will give an indication of what we're seeing and thinking of, because we don't want them blindsided, because they don't like the worst thing you can do to them is blindside them and then have the governor come down on them. So we try to keep a very good working relation. And we know if we tell them something, it's not going on to Twitter, it's not going on to Facebook, and it's not going to the newspapers until we're done. So go ahead, Jim. Challenges, again, for our office is getting more staff members trained in conducting storm surveys, because, especially now, we've had a huge turnover of staff. So, and we don't get these type of storms, that are worthy of surveying every day. So to try to be able to hit them all and get people out there, um, it requires a little creative rescheduling on our part. We also have a flyaway kit, so you can go in and get on the road quickly, because you want to get out there before the DPW departments have the stuff all picked up. And believe me, if you wait, I've been in some cases where if I had been an hour or two later, the evidence would have been gone. Because let's face it, these people need to get their roads open so their residents can get to work or wherever they need to get. And then the other one is to work with our media partners to facilitate the interviews. Prep briefings have to be scheduled where, one, everybody can be there, and two, it doesn't disrupt our flow of our inspection. So that's why you give them set times. And the office ensures continuous flow of information to social media as we're going along. They won't put out how strong we think it is, but okay, they've moved to this town or that town. So
All right.
that's it from my end. So
Yeah. Thanks, Alan,
do you
very
have
much.
a question, Joe?
Yeah, well, again, use the chat if you have some questions. I think we have some in there already. So let me go ahead and take a look. So let's see. So John has a question. Was a storm damage survey done for the wind damage event at Mount Tom in October 2014? Yeah, I believe it was, Alan. I'm not sure who went out there. Did
It
we?
was me, Joe.
It was you. I thought it was you.
Yep.
Yeah. That was one that occurred early in the morning, just prior to rush hour. So you were the lone one to go out there?
Yeah, I was all by myself. And also, remember that one that Hayden had? We had the tornado during the overnight hours.
Yeah, that was Concord. Yeah.
That Hayden went ahead and issued. Yeah, I was a lone stranger on that one, but I got woken up with a phone call. Get in here. You're heading out.
So as everybody can probably tell, Alan is our first choice for most of our damage surveys. But that's because you do a thorough and excellent job, Alan. So there you go.
I try.
There you go. Let's see, from Tom, do the sliders lack foundation tie rods?
In most cases, yes.
Yeah, they were just kind of.
If you looked at those, they were basically just sitting. That was the way they constructed them back then, and they were just sitting on the granite blocks for the most part.
Yeah, we were kind of surprised. They weren't fastened. It was just like they were plopped right on top of the foundation, and that was it. So kind of surprising. And that was some of the older homes. That's what they did. So, and a question from John: do storm surveys correlate well with what you expect from the radar, or are you often surprised? That's a good question.
Yes and yes. Sometimes they correlate really well, and you actually find what you have a kind of an idea of what you're going to find. When I'm getting ready to do a survey, I look at the radar and everything else, but I do not go out with a preconceived, I'm going to see this, this, and this, because that could go ahead and influence my judgment of doing an accurate survey based on what I'm seeing on the ground. Because radar, it's good indication, but until you get out there and get on boots on the ground, talk to the people that may have seen it or witnessed it, made sure that see if they had got the alert. You can't go. You can go out with a general idea of what you're going to find. The radar is real good for telling you where to look, but but there have been times when I've gone out and I've been completely blown away because I did not expect what I saw with the radar, and it's been both ways. Either a lot more damage or, gee, look at the radar. There should have been a crud load of damage, and it's only a few trees. So it can work both ways.
Yeah, and I think, Alan, you also were on the Cape Cod tornado survey, and
Yep.
that one was, I think, pretty much as expected. But I remember the one that surprised you. Was it Wendell out in Franklin County?
Yes.
And I forget the year of that. That was a while back. We thought it was just a little wind damage, and you came back. Oh no, we had an EF2. I'm like, whoa.
Yeah. Yeah. That was a, well, can you just, if you don't have anything else, can you just head on out there? And it's like, okay, yeah, that's fine. And so I headed out there. And that was another case where, oh, this will take me 2 hours, was about 5 hours of documenting everything. That's the one where I left the fire department and the police officer in the dust as I went up the hill. So that's when I called in and I said, no, guys, we had a tornado here and I hope we had a warning out, which we did.
Yep, I remember that one. Let's see. Question from MJ. The Revere tornado, and that was in 2014. What was the EF number on that one? And what evidence did you gather from that? So that was an EF2. That was July, I think July 28th, 2014, was the
That
day
was
of
the
that.
Glenn inspection.
Yeah, Glenn Field surveyed that one. He happened to be in Boston that morning at a doctor's appointment, and then we had the tornado. It was a little before 10, I believe, or just after 10. So we got him on the phone, and he went over to Revere, and that was actually mostly in the urban environment, which is kind of rare for us to see here. There was a lot of damage. I remember, Alan, to homes, but also to some businesses. There was
Yep.
one garage car repair place that was damaged. I believe it was mostly, residences and buildings for the most part.
Oh, yeah, because there were no trees.
Yeah, that was right in Revere, and that was a very brief touchdown, but an EF2, pretty impressive. It was just on the ground, I think, for a minute or two, and lifted right back up. Let's see, from my friend Fred. He was in Wilbraham a few days after the tornado, was surprised it did extreme damage on one side of the street, jumped over the middle school. Amazing aftermath. Yeah, and Alan, that's the other point too. With the tornado, the damage is often highly localized. One side of the street could have a lot of damage, and the other side has nothing. So that's,
And they can also pick up briefly.
yep.
You can almost get a hopscotch effect
Yeah,
where
sometimes
it's,
you have almost multiple touchdowns where it jumps up and down, especially when it's in hilly terrain. We see that quite a bit.
mhm.
So, and let's see, from Gary, is there any correlation between the tornado width and the EF rating?
I don't think so. I
Not
haven't
really.
noticed that.
Yeah, I mean, most of our tornadoes are, several hundred yards width, June 1st aside. But yeah, most of ours are there, but there's really no direct correlation. Stronger tornadoes, I would think, yeah, they're probably a little wider, but no, no, nothing direct there, Gary. All right, so that looks like that is all the questions for now. So